Section 9.5 is on hyperbolas. The definition of a hyperbola is the set of all points in a plane such that the absolute value of the differences of the distances from the foci is constant. Here's another cool little video that I found that shows this. And to be honest, since this only shows one focus, it isn't really showing both foci, but anyway, there is a geometric way that you can graph out a hyperbola. But let's go back to some of the information we need to learn here. So the standard form of the equation of a hyperbola is x minus h squared over a squared minus y minus k squared over b squared equals 1. Notice this is a lot like the equation of an ellipse, except in here we have a minus instead of a plus. In this video, we're only going to focus on horizontal hyperbolas, that is, ones that open up left and right, and the vertices and the foci lie on a vertical line. If y comes first, so if I were like put this y minus k in the place of x minus h, then the hyperbolas would open up and down, but we're not going to focus on those right now. We're just going to focus on horizontal ones. So here's some information you need to know about a hyperbola. And again, as we did with the ellipses, it looks very complicated, but it's going to be very easy when we start to graph it and can kind of discover some of this. So the center is at point HK. The foci, vertices, and covertices, here are the formulas for those. But the key thing to remember is we have this equation here, c squared equals a squared minus b squared. Okay, and where do we get the a, b, and c from? So the distance from the center to each of the foci is c units. So from center to a focus is c units. From the center to a vertex is a units, and from the center to a covertex is b units. We have something called the transverse axis, which is a segment that runs between the vertices. Its length is 2a, which makes sense because it's going to go from vertex to center and then center to vertex. The conjugate axis is the segment that goes between the two covertices, and its length is going to be 2b units. And then hyperbolas have asymptotes, and the equations of the asymptotes are y equals plus or minus b over a times x minus h plus k. Actually, I'm going to show you an easier way so you don't have to memorize that. So here's some information from your textbook that gives you the same information for equations of hyperbolas centered at the origin, and we are not going to do those. Equations of hyperbolas centered at HK, which I think is good to just kind of do in general, and we're not going to do the vertical ones. And this is what a vertical one looks like, but we're not going to do that one. Here's what it's going to take a look like. You'll have your center here, and your vertices are at V1 and V2. Your foci are out here, again, inside kind of the little bowl. You'll notice that we actually are going to draw a little box, a little rectangle. That's very cool. It helps us to draw it. These are the asymptotes, the kind of pink dashed lines, and we'll be finding the equations of those. And then the hyperbola goes in here, hits the vertex, and since these are asymptotes, doesn't hit the asymptotes, and that's going to be on both sides. So let's do a couple examples like you're going to see in the textbook. So this one says write an equation for this graph. So you can see the blue line is the hyperbola. The pink lines are the asymptotes in the box that you have to draw. First thing I'd like to do is identify the center. So my center for this one is really easy. It's at 0, 0. So that means h equals 0, k equals 0. Okay. A, remember, is the distance from the center to a vertex, and this is the vertex right here where the hyperbola hits it, and that's 5 units. And B is this other distance here from the center going up to there, and it doesn't look, I can't find that quite exactly. That's not very good, so we'll have to figure out what B is. But C is the distance from the center to a focus, and that's this blue dot out here, so my C is 7. Using that, using c squared equals a squared plus b squared, I can find the exact length of b because I can't quite tell from looking at the graph. So 49 equals 25 plus b squared. So b squared is 24, or b is going to be the square root of 24. Okay, now let's go ahead and plug this into our formula. Remember, our formula looks like this: x minus h squared over a squared minus y minus k squared over b squared equals 1. So all I need is h, k, a, and b, and I have all of those values here. So since h and k are 0, I have x minus 0 squared. That's just the same as x squared over a squared is going to be 25 minus y squared. I don't want to put a 0 in for k. Over b squared was 24, and that equals 1. And that's the equation for that hyperbola. Now here we're given the equation of a hyperbola, and we have to graph it and identify the vertices, the foci, and the equations of the asymptotes. So to graph this, I'm going to start by graphing the center. So my center is at the point 3, negative 2. So 3, negative 2, there's my center. And 25 is a squared, so a is 5. And b is going to be 2, because this is a squared and this is b squared. Now I'm going to draw the box. So from the center, I'm going to go 5 units to the right, 5 units to the left, and b, from there I'm going to go 2 units up and 2 units down, and I'm going to draw my box. So it needs to be 2a units long, so 2a units this way and 2b units this way. Okay, now I can draw my asymptotes, and they go diagonally through the box. It's a little hard to draw those exact. Okay, but they do go through the corners of the rectangle here. Okay, so these points here are my vertices, and my hyperbola is going to look like this, because we're only doing ones that open left and right. And notice how it's asymptotic to the lines. It doesn't quite hit the lines. So my vertices, I can just read those off of the graph, are 8, negative 2, and negative 2, negative 2. Okay, now I need to find the foci. So to do that, I need to know what my value of c is. So I'll use c squared equals a squared plus b squared, or that's equal to 25 plus 4. So c is equal to the square root of 29, which is approximately 5.4. Now remember, c is the distance from the center to the focus. So 5.4 units to the right and to the left. So 5 units gives me my vertex, so my focus is going to be right about there. And then 5 units gives me this vertex, and so my focus is going to be right about there. Now, what are those coordinates? Let's just count. So this was 8 out to here, and then I need it. So that's 5 to there, and then another 0.4. So that's going to give me 8.4, comma, negative 2. And then over here, 5.4. So I went 2, so to negative 2, and then another 4.5. I'm sorry, another 0.4. Sorry about that. Let me say that again. So from the center, 5.4 in this direction. So 5 gets me to the vertex, which is at x equals negative 2, plus another 0.4. So it's going to be negative 2.4, comma, negative 2. Now to get the equations of the asymptotes. I could use that formula, but I think I just like to count for the slope. So I've noticed one of these has a positive slope and one has a negative slope. So my line that has a positive slope, it's going through the center and this point here at the corner of the box, so I went up 2 and right 5. And then my one that has a negative slope, I'm going down 2 and right 5, so that's a negative 2/5. Okay. And then let's pick a point on that line. Let's do the positive slope first, so that's the point 8, 0. And I'm just going to use point slope form. So y minus y1, y minus y1 equals m times x minus x1, and that's going to give me y equals 2/5 x minus 16/5. Now for my other line, I think I'll use this point here, 8, -4. So y minus, oh dear, sorry about that, y minus y1 equals m times x minus x1, and that's going to give me y equals -2/5 x, and then that's going to give me 16/5 minus 4, just use your calculator, gives you a -4/5. So those are my equations of the asymptotes. I found my vertices, and I found my foci, and the blue line is the graph of my hyperbola. And our last example here gives us the equation of a hyperbola in general form, so we need to put it into standard form so I can read off my center and my A and my B. So as we did with an ellipse, we're going to group together our x terms, group together our y terms, move our constant to the other side, and then complete the square. So 16x squared plus 128x minus 9y squared plus 36y equals a -76. So in order to complete the square for each of these, I'll have to factor out the coefficient of my squared variable. So it's going to give me 16 times x squared plus, let's see, what does that end up being? I think that's 8x. Okay, and then over here I'll factor out a -9, and this is a little tricky, so that's going to change the sign in front of the 36 to a negative. Okay, because when I multiply, I'm going to do a -9 times -4 to get 36 equals -76. Now let's complete the square inside the parentheses. So half of b squared is 16. And again, I didn't just add 16, I really added this 16 times this 16, which is 256. And completing the square here, half of b squared is a +4, but I didn't really just add 4, I really subtracted 36. So that's going to be a -36. And now let's clean that up. So 16 times x plus 4 squared minus 9 times y minus 2 squared equals, that ends up being 144. And since my equation has to equal 1, I'll divide everything by 144. And that gives me my equation as x plus 4 squared over 9 minus y minus 2 squared over 16 equals 1. And now, let me give myself a little more room here. Now from that equation, I can identify my center, which is at -4, 2, and A is going to be the square root of 9, which is 3, and B is going to be the square root of 16, which is 4. So let's use that information to go ahead and graph this. So my center is at -4, 2. A, so I'm going to go 3 units to the right, 3 units to the left. B is up and down, so up 4 from the center, down 4 from the center, and now I can draw my rectangle. Okay, I can also draw in my asymptotes, which are the diagonals of that rectangle. And from here, that's actually enough information to go ahead and graph it, because I know I'll have a vertex here and a vertex here, and it curves out toward the asymptotes like that. So there's my graph. So now I need to find some of the information. So my vertices are at -1, 2, and I can just read them right off of the graph. And what is that? Let's see, what is that? -7, 1, 2, 3, 4, 5, 6, 7. negative 7, 2. And I think I need to find my foci. So remember, to find the foci, we're going to use c squared equals a squared plus b squared. Let me move that up, give myself a little more room to write. So I need to find c. So that's going to be 9 plus 16 is c squared, which is equal to 25. That's a nice number. So c is equal to 5. So remember, that's the distance from the center to each focus. So from the center, go 5 units out, and this is a nice one. I end up with a nice point here. From the center, 5 units out. So my foci are at the points 1, 2, and negative 9, 2. Now I need to find the equations of the asymptotes. So remember, one is going to have a positive slope and one is going to have a negative slope. So the one with the positive slope is up 4 and right 3, so that's 4/3. The one with the negative slope is going to be down 4 and right 3. Let's pick a point. I think I'll use this point right here, which is negative 1, 2, 4, 6, negative 1, 6. And I'll use this point, negative 1, negative 2. So y minus 6 equals 4/3 times x plus 1, or y equals 4/3 x, and then 4/3 plus 6 gives me a positive 22/3. There's one of my lines. And the other one, y minus a negative 2 equals negative 4/3 times x plus 1, or y equals negative 4/3 x, and that gives me a negative 4/3 minus 2 is a negative 10/3. And those are my two equations of the asymptotes. And I think I did everything I was supposed to there. So in this lesson, we took a look at hyperbolas, which look something like this. They're a little bit difficult because there's so many details to worry about, but actually if you just step through, draw it as you're identifying all of the parts, as you're identifying the center, and then draw the box with the A and the B. That'll give you the vertices. Use c squared equals a squared plus b squared to find the distance from the center to the focus, and then just count and use some basic algebra to get the equations of the asymptotes.